this assessment, we're asked to predict the product of an epoxide reaction, an epoxide addition reaction with a nucleophile we haven't seen before, in this case, an organolithium. Now, one of the ways that we can get started on this problem is to recognize that anytime we have a carbon-metal bond, we can kind of think of it as if it's ionic. So we would have a negative charge on carbon and a positive charge on lithium. By considering it as this ionic structure, what we realize is this is a very powerful nucleophile. That negative charge on carbon is going to be really unstable. We know that from the pKa of a CH bond of being around 50. So this is a really powerful nucleophile. And epoxides react with strong nucleophiles. We've seen that previously. If we react this as a strong nucleophile with the epoxide, we have a choice to add it to the primary or the secondary carbon. Strong nucleophiles add to the least substituted carbon because these reactions are SN2-like. Now, one of the things that's going to be helpful on a problem like this is to number our carbons. So let's number these 1 through 4, and we'll number this carbon 5, carbon 6, and we'll just let carbon 7 be what starts the ring. It's really important to make sure we've counted our carbons correctly so that our understanding of the chemistry is not compromised by simply miscounting carbons. And so we can draw in that benzene ring with the methyl group coming off. That was carbon 7. We'll go up to carbon 6, down to carbon 5, up to 1, 2, 3, 4. Let's put those numbers in because I might have messed this up. Let's see. This is 7, 6, 5. We've made a new bond between carbon 1 and carbon 5. So that's 1, 2, 3, 4. At this point, we can decorate. Carbon 6 had a dashed oxygen and a bold wedged hydrogen. Those are still going to be there. We can put the hydrogen here, and we can put the oxygen here. Now note that oxygen picked up a pair of electrons, so it's now going to have a negative charge. This is the product of step 1, but we don't tend to isolate alkoxides as products. Instead, we're going to do an acid quench, where we react this alkoxide with H3O+, simply protonating that negatively charged oxygen to give us our final product, which we can draw as follows. We can number the carbons once again, just to make sure we haven't lost any. 4, 3, 2, 1. We formed the 1,5 bond, 5, 6, and 7. The carbon numbering checks out, and so that is the product of this reaction.